This is your reality check.
Welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. Today is June 16th, and I'm producer Pat, and well, it's shaping up to be a busy summer for the TRC crew, so today it's just me. Fear not, we still come to you with a show, something we call a mashup, where we take segments from different shows and mash them together based on a theme. This week's theme is effects, and we kick things off with Darren from episode 382 talking about the Dunning-Kruger Effect. A note on this segment, you will hear a voice that you may not recognize. That's friend of the show and occasional guest panelist, Dallas Card.
We covered the Dunning-Kruger Effect back in episode 179, but I wanted to briefly revisit the topic because the effect is commonly misunderstood, or at least not fully understood. Dunning's own words in a Pacific Standard article, which will be linked in our show notes on our website, trcpodcast.com.
Great website.
And this is a quote. In 1999, in the Journal of Personality and Social Psychology, my then graduate student, Justin Kruger, and I published a paper that documented how, in many areas of life, incompetent people do not recognize, cannot recognize, just how incompetent they are. A phenomenon that has come to be known as the Dunning-Kruger Effect. Logic itself almost demands this lack of self-insight. For poor performers to recognize their ineptitude would require them to possess the very expertise they lack. To know how skilled or unskilled you are at using the rules of grammar, for instance, you must have a good working knowledge of those rules, an impossibility among the incompetent. Now, Wikipedia says something similar. The Dunning-Kruger Effect is a cognitive bias in which relatively unskilled individuals suffer from illusory superiority, mistakenly assessing their ability to be much higher than it really is. Dunning and Kruger attributed this bias to a metacognitive inability of the unskilled to recognize their own ineptitude and evaluate their own ability accurately. Now, it's commonly phrased and discussed as if stupid and or incompetent people are too stupid and incompetent to know they are bad at something. Yes, that is true in the graphs of the original study, that those who did worst were most wrong about their abilities in a range of tasks. But that's not the whole story. First, the opposite does also apply in that those who are highly competent tend to underestimate their ability compared to others. Those who are good at something might think they are average and don't realize how good they are, or they've developed an expertise and don't realize that that level of skill isn't common in the general population. Further research conducted by Burson et al. In 2006 set out to test one of the core hypotheses put forth by Kruger and Mueller in their paper Unskilled, Unaware, or Both. And this is a quote, that people at all performance levels are equally poor at estimating their relative performance. To test this hypothesis, the authors investigated 3 different studies, which all manipulated the perceived difficulty of the tasks and participants' beliefs about their relative standing. The authors found that when researchers presented subjects with moderately difficult tasks, the best and the worst performers varied little in their ability to accurately predict their performance. Additionally, they found that with more difficult tasks, the best performers were less accurate in predicting their performance than the worst performers. The authors concluded that these findings suggest that judges at all skill levels are subject to similar degrees of error. So, a broader and perhaps better interpretation of Dunning-Kruger is that most people are poor at assessing their competencies. That was the important point number 1 that I wanted to highlight, which we did talk about in the previous episode, but I thought I wanted to bring more attention to it. A second related one is to understand that we are all bad at something, or many things. I really think this point is not sufficiently acknowledged when the Dunning-Kruger effect is discussed. And I'll now quote from a great post by Stephen Novella, who wrote that the Dunning-Kruger effect has a strong relationship to confirmation bias. It's a quote. As we try to make sense of the world, we work with our existing knowledge and paradigms. We formulate ideas and then systematically seek out information that confirms those ideas. We dismiss contrary information as exceptions. We interpret ambiguous experiences in line with our theories. We remember, and then our memories tweak any experience that seems to confirm what we believe. In the end, we are left with a powerful sense of knowledge, false knowledge. Confirmation bias leads to a high level of confidence. We feel we're right in our gut. And when confronted with someone saying we are wrong, or promoting an alternate view, some people become hostile. The Dunning-Kruger effect is not just a curiosity of psychology, it touches on a critical aspect of the default mode of human thought, and a major flaw in our thinking. It also applies to everyone. We are all at various places on the curve with respect to different areas of knowledge. You may be an expert in some things, and competent in others, but will also be toward the bottom of the curve in some areas of knowledge. Admit it. Probably up to this point in this article, you were imagining yourself in the upper half of that curve, and inwardly smirking at the poor rubes in the bottom half. But we were all in the bottom half some of the time. The Dunning-Kruger effect does not just apply to other people, it applies to everyone.
So it seems like if the underperformers are overestimating their performance and the overperformers are underestimating their performance, there should be someone in the middle who's getting it about right. No?
That is correct. Now, in the original study, if you picture a graph in your head, X and Y axis, and there's a bit of a diagonal line and then a straight line, where the straight line, we'll just say, is performance, and the diagonal line is the estimation of performance, and they cross at one point. It's kind of like if you do the first, the second, the third, and the fourth percentile, everyone thinks their third percentile of ability, but only the third percentile is right. So the first two are dramatically off, and then the last one's off, but in the other direction. That's what the original study seemed to show. So it seemed like everyone just kind of thought they were above average, but not highly superior. But the subsequent research seemed to indicate a mixture of effects, things that are all kind of all over the place, which then made me doubt the consistency of that finding that someone's going to get it right, because it seemed to be too diverse, depending on what we're looking at. As well, I'm just trying to think, there's so many different things you could talk about in terms of how do you assess like humor or leadership or competency in certain domains that it'd be far harder to pin down as a consistent effect.
Sure. Is there any way to know if we're suffering from the Dunning-Kruger effect?
That's a great question. I think the best thing you could try to do is first look at your own abilities with some objective metric, and then get someone else to try to assess you with a similar objective metric. Or try not to define certain terms in a way that you automatically benefit from. So if someone asks, what are your skills of leadership, try to find a popular definition of leadership, not the one that you may think suits your qualities best. Because that's another thing that, I think I'm above average because I define leadership this way. But if you also pick something else, like are you good at math? What does good mean? What does math mean? Math is really just straightforward. What does good mean? And then you could just ask your friends, am I good at this? Or no. Better yet, ask your enemies. They'll tell you suck. But yeah, there must be some way to try to get around this. And I think that's sort of like the scientific method. You have to go beyond your personal experience, beyond your own anecdotes of how good or bad you might be at something, and then try to get a collective view.
But something like math, presumably there's standardized testing that you could take and then see in what percentile you fall, right?
This is true. Yeah. But you could also say, let's say I might be good at doing arithmetic in my head, but I'm not necessarily good at differential equations.
Right.
So am I good at math? Well, yes or no, or both. I think you just really ask yourself a precise question, I think could be part of it.
Right. So
for my conclusion, I think it's best to just say the title of that article that Dunning wrote in the Pacific Standard. We are all confident idiots.
From the Dunning-Kruger Effect, we move to bias against acknowledging the achievement of women scientists, something known as the Matilda Effect. This is Cristina from episode 456.
I finally got a chance to watch the movie Hidden Figures on a flight home from Paris last week. Have you guys seen that flick yet?
No, but I've heard good things.
Oh, it's so good. Highly recommend. Hidden Figures is based on the story of a team of female African-American mathematicians, aka computers, who served a vital role in NASA during the early years of the U.S. space program. One of the main characters, Katherine Johnson, calculated the trajectories, launch windows, and emergency backup return paths for several flights from Project Mercury, the early NASA missions of John Glenn and Alan Shepard, and the 1969 Apollo 11 flight to the moon.
Wow.
She was so bright, she was accepted to college at age 14, and a couple of years ago, at age 96, she was awarded the Presidential Medal of Freedom. Now, what surprised me most about this story, and I've heard other people say this too, is that I'd never heard about Katherine or any of these women's significant contributions until this movie came out. So that's pretty sad to say, but true. Now, when Johnson was asked in a recent interview for the LA Times, did you ever have to go toe-to-toe with the NASA engineers over the numbers? She replied, after a while, they learned to respect my answers because they were always correct.
That's great.
In a couple of scenes, Katherine is typing up technical papers with her calculations and boldly decides to cite her name alongside the lead engineers, who's played by Jim Parsons from Big Bang Theory. When he sees her name next to his, he immediately rips the top page off the report and reminds her sharply that computers don't author papers.
Oh. Wow.
Yeah, snap. Now, while watching the movie a second time with Pat, knowing I hadn't settled on a topic for this week's show, he suggested doing a segment about men who have historically taken credit for women's scientific achievements. And there's a lot of them, so here we go. Now, we've often talked about the challenges women who pursue STEM careers face on TRC in the past. For those who may not know, that's science, technology, engineering, and math. For much of history, women weren't even allowed to publish in scientific journals, let alone get funding for research. But even as this changed, female scientists were still being overlooked. And that's where the term the Matilda Effect comes in. It was coined in 1993 by science historian Margaret W. Rossiter. The Matilda Effect is a bias against acknowledging the achievements of women scientists whose work is often attributed to their male colleagues. Happens so much they needed a name for it, huh? Now, this effect was first described in the 1800s by suffragist Matilda Jocelyn Gage in her essay, Women as Inventor. The Matilda Effect is related to the Matthew Effect, which you guys may have heard of, whereby an eminent scientist often gets more credit than a comparatively unknown researcher, even if their work is similar or shared. Now, according to the Wiki, from an analysis of more than 1,000 research publications from the years 1991 to 2005, so more recently, it was shown that male scientists more often cite the publications of male authors than of female authors. In 2012, 2 female researchers from Radboud University in the Netherlands showed that the sex of professorship candidates influenced the evaluation made of them. Similar cases are described and corroborated by other studies.
Cristina, I assume this was some sort of ratio, because I assume there just would be more male scientists that are publishing papers.
It's a good point, Darren. I'm not sure of the answer.
Okay.
So in the U.S., male scientists still receive more recognition and awards compared with women scientists, despite having similar achievements, although this is thankfully happening less in the 2000s than in the 1990s.
Go 2000s.
A neurobiologist at Stanford University Medical School named Ben Bars, who transitioned from female to male, has spoken out about his personal experiences and how his scientific achievements were perceived differently depending on his sex at the time. I thought that was very interesting.
Well, there's your control study in a way.
Yeah,
it's a so-called natural experiment where you can actually change the A to the B.
Oh,
Yeah. So I thought I'd give you guys a couple of the more egregious and well-known examples of groundbreaking scientific discoveries where women got shafted out of the credit. Lisa Meitner, born in 1878, was an Austrian-Swedish physicist who worked on radioactivity and nuclear physics during the World War II era. She was the first to hypothesize nuclear fission. Working alongside a chemist named Otto Hahn, they led a small group of scientists who worked on experiments with uranium, but during the annexation of Austria into Nazi Germany, Meitner, who was Jewish, left Stockholm while Hahn and his partner Fritz Strassmann continued their work. When the male scientists were perplexed by how the uranium seemed to form atoms they thought were radium when bombarded with neutrons, it was Meitner who posed the theory that the atom may have broken down after bombardment into what was later realized to be barium. She also observed that no element larger than uranium existed naturally, and that the fission process, which splits the atomic nucleus of uranium into 2 smaller nuclei, had the potential of creating enormous amounts of energy. This process, of course, is the basis of nuclear weapons that were developed in the U.S. during World War II and used against Japan in 1945. Now, this discovery had huge implications for the world of chemistry, but her role was severely downplayed by her male counterparts, who went on to win a Nobel Prize for their discovery in 1944 with no mention of Meitner. The prize committee later claimed this to be a mistake, but that's what happened at the time. While she didn't receive formal recognition for her discoveries, she did go on to be the first woman to become a full professor of physics in Germany and received many posthumous honors, including having chemical element 109, meitnerium, named in her honor in 1997, which is pretty cool.
Very cool.
Mm-hmm.
Another famous example is astrophysicist Jocelyn Bell Burnell, who, inspired by her dad, began her work in astronomy, and in the late 60s, when she was a 24-year-old PhD student, began working under Anthony Hewish studying quasars. Now, she spotted an anomaly on a graph buried within 100 feet of printed data from a radio telescope. She noticed specific and constant signals were being given off by something in space. Her curiosity led to one of the most important discoveries in 20th century astronomy, the discovery of pulsars, which changed the way we see the universe, making the existence of black holes more plausible and lending further credence to Einstein's theory of gravity. Her observations were quickly acknowledged and published, with her thesis supervisor Hewish's name appearing before hers, even though he initially expressed skepticism of the anomaly and was insistent it was man-made and due to interference. So even though Bell Burnell made the discovery, Hewish later won the 1974 Nobel Prize in Physics, which he shared with astronomer Martin Ryle for his discovery of pulsars. She never received formal credit. It is well known and accepted that she was the first person to make this observation. Finally, I want to mention Rosalind Franklin, who is perhaps one of the most well-known and shameful examples of a researcher being wronged by her male colleagues. Franklin was a brilliant scientist who used X-rays to take a picture of DNA that would change biology. Franklin had a doctorate in physical chemistry from Cambridge, spent a few years in Paris Institute learning X-ray diffraction techniques, and then returned to King's College in England as a research associate at John Randall's lab, who's the physicist credited with inventing radar. It was there where she came to know Maurice Wilkins, who was the assistant director of the lab leading his own research group studying DNA structure. You guys may be familiar with the names Watson and Crick.
Mm-hmm.
No? So those are the two scientists credited for the discovery of DNA structure, or famously credited. So Watson and Crick were competing scientists, also trying to determine the structure of DNA, but at the time they were barking up the wrong tree. Franklin, however, had figured out that DNA consisted of a three-dimensional double helix structure confirming the shape with X-rays. When Watson and Crick visited King's College, Wilkins, without Franklin's knowledge or consent, shared with them the reports of her findings and the now famous X-ray image that Franklin took, which was a major key to understanding the double helix structure of DNA. Watson and Crick went on to use her findings as the basis of their DNA model, publishing a series of articles in the journal Nature in 1953, excluding her and even insisting she publish any of her findings after they did.
Wow.
Watson and Crick went on to win the 1962 Nobel Prize in Physiology or Medicine and had their images plastered in biology textbooks, while Franklin's research was perceived as more of a confirmation of their work as opposed to it being her own discovery, which is very sad.
Mm-hmm.
Now, Watson went on to publish a memoir in 1968 called The Double Helix, and he included this choice passage in describing Rosalind Franklin. By choice, she did not emphasize her feminine qualities. She was not unattractive and might have been quite stunning had she taken even a mild interest in clothes. It was quite easy to imagine her the product of an unsatisfied mother who unduly stressed the desirability of professional careers that could save bright girls from marriages to dull men.
Wow. Classy British wit right there.
Yeah. So these are just a couple of many, many, many examples of women who did not get the credit they deserve for their groundbreaking discoveries. And you'd hope things have changed significantly by now, but this is still happening. In 2015, a Harvard PhD student, Heather Sarsons, published a study that looked at the tenure process at top economics programs. She looked at 4 decades of records on over 500 tenure decisions at the top 30 economic schools in the country. What she found is that while men receive the same professional credit for solo-authored papers as for work done with a woman or another man, women were not properly credited for their work when they co-authored a paper with a male colleague. In the footnote of her study, she made sure to write, "This paper is intentionally solo-authored." So there you have it. It's actually pretty interesting when you dive into it. And if people want to check out the links at trcpodcast.com, there's a lot of great stories of women who've done some pretty amazing things in science.
The last segment I wanted to play for you today is something that demonstrates the interaction between hearing and vision in speech perception, something known as the McGurk Effect. Darren did a segment on wine tasting bias on episode 458. He looked into some reports claiming that the color of wine can influence your perception of the taste, and it appears that it can.
That was a great segment.
Mm-hmm.
So, for example, when white wine was dyed red, it was perceived in many cases as having the odor of red wine.
To your credit, Darren, I think I've cited that segment more than any other segments in the past few weeks.
Which maybe says more about you than...
about how much I drink wine.
Hey, let me tell you guys something. If this wine was a different color, shut up. Maybe you should shut up.
So it was a checker who goes by the handle Evil Eye who posted a comment about that segment suggesting that this was similar to the McGurk Effect, which I had never heard of. So what is the McGurk Effect? I'll do my best to describe it, but to really get a feel for how this messes with your perception, you kind of have to see it. I've linked to a couple of video examples in the show notes, and it's pretty amazing to watch. In particular, a BBC clip from the show Horizon is Seeing Believing. Professor Lawrence Rosenblum is shown close up speaking a phoneme or syllable. Essentially, he's saying ba, 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 ba with a B over and over again. Next, the video is swapped out. In the video, he's making the mouth movements for the sound va, 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 va with a V. And that's exactly what you hear, or what I heard, even though the audio track has not changed. All you need to do to confirm it is to close your eyes, and the audio switches back from va with a V to ba with a B. The McGurk Effect was first described in 1976 in a paper by Harry McGurk and John MacDonald titled Hearing Lips and Seeing Voices. It was discovered by accident when McGurk and his research assistant MacDonald asked a technician to dub a video with a different visual from the one that's heard. They were conducting a study on how infants perceive language at different developmental stages. But what it ended up demonstrating is that visual information is integrated into our perception of speech automatically and unconsciously. In one example, the syllables ba 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 with a B is spoken over the lip movement of ga 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 with a G. And this is where it gets weird. When they reviewed the video, both researchers heard a third sound, da 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 with a D. And so do many people. The McGurk Effect is essentially an illusion, and it doesn't matter if you know exactly what's going on. And this is perhaps one of the most interesting things about the effect. Even when the viewer knows what's happening, it still works. In other words, even though I know it's an illusion, my brain can't seem to turn the effect off. That said, it does work on most people, but not everyone is susceptible to the McGurk Effect. There was a study done last year on 80 professional musicians with at least 8 years of musical academic studies. They mixed and matched audio and video using the syllables la with an L, da with a D, ta with a T, ga with a G, ka with a K, na with an N, ba with a B, and pa with a P. Overall, there was no significant McGurk Effect on the musicians for any of the syllables, while the control group, who were presumably not musicians, showed a significant effect. They're not sure what's going on, but they speculate that musicians with this sort of intense training are so focused on auditory information, it may affect the way that their auditory cortex processes the syllables.
Could drugs inhibit some of these processes?
Could be. But these seem to be classically trained musicians, so I'm not sure that would be the case.
You are making the assumption that all musicians do drugs.
I believe that's the null hypothesis you have to test against.
They measured specifically for experience, so I'm assuming that they don't think that it's, say, a certain way of thinking or a certain inclination of a person who is more interested in pursuing a career in music that might have inclined them to perceive differently?
Right. So I don't know the answer to that, Adam, but what they did was they just tested people who had already followed that career.
Yeah.
Good question, though.
So wait, now that we're here, what about you guys? I sent a video. Did anyone give it a try?
I have.
I did.
Yeah? And what did you think?
It's so strange because I know he's saying ba, but when you watch him, you're certain you're hearing fa. So it worked on me. And I know we tried it as well on Thanksgiving on a relative, and she was astounded.
Right. Darren, what about you?
Oh, yeah, it very much worked on me. I said I had some memories from my psychology class many years ago, but I don't think I've seen a video of it in quite some time, and it was compelling. He would say ba with a B repeatedly, and you're like, that makes sense. Then he says ba with a F movement of the lips, and you hear it as fa with an F. And I couldn't unsee it, and then when they put them side by side, it still looks like he's kind of saying it, but my experience was that the ba with a B sound was coming through, and it's like the program or his setup just muted the F sound, even though it was never there in the first place. So that was an interesting effect. But yes, like many powerful illusions, which I think are great tools for education, once you see them and then know about them, you still keep seeing them.
Mm-hmm.
So we actually had a bit of a back and forth about this when I sent you guys the video, and Darren wondered about how broad the effect was since they mostly pick very similar sounds. So it's true. It does work better with certain consonant pairs than others, and clearly from the videos I've seen, ba, va, ga, da are the most common ones used for demonstrations. That said, it does work in every language that has ever been tested.
Wow. Apparently
it's strongest in Dutch, English, Spanish, German, and Italian, and weaker in languages like Japanese and Chinese. So, some more interesting stuff about the effect. It's been observed as having an effect on children as young as 5 months of age.
Wow.
It works even when the video and audio aren't precisely synced. It works even if you are the person being observed, so even if the video and audio is of yourself. It works even when the audio and video are from people of different genders. There's some reduction of the effect in people with disorders such as schizophrenia, Alzheimer's, and autism. So that's the McGurk Effect. And it's a pretty cool illusion. Again, I've linked to several video demonstrations in our show notes. I really suggest you guys go and check it out for yourselves.
Yeah, super fun.
Well, we hope you enjoyed this week's mashup all about effects. We talked about the Dunning-Kruger Effect, the Matilda Effect, and the McGurk Effect. The whole crew will be back with a brand new show next week. Until then, think better to act better. Peace out, cuboids. Stay classy, not smartassy. And we'll talk to you next week, everyone.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at @TRC_podcast.